All right, looking at the last three application problems from 15.8, this number 12 here talks about the blood, the amount of milligrams of a substance in the blood after a certain amount of time. And in this problem, they talk about 25 milligrams taken at the start time. So this is the start time, remember, or start milligrams, okay? And then after a certain amount of time, that's going to reduce to 10 milligrams. So we've seen this before in some of the other application problems, but what I'm going to do is I'm going to divide by 25 and divide by 25, okay? And I could write that as a decimal or as a fraction, but this will reduce to 0.4, and 0.4 equals e to the negative 0.8t. Okay, we're solving for t, so we could take the natural log of both sides here. On the left side, I get the natural log of 0.4. On the right side, I get negative 0.8t. After these cancel out, I'll divide by negative 0.8 and divide by negative 0.8. And what I find out for t is that t is approximately 1.15 hours. Okay. So it'd take about a little over an hour for to reduce from 25 milligrams to 10 milligrams. Okay. Now this next problem talks about how the pressure decreases as an object goes up into the atmosphere. And so this is initial 15 pounds per square inch, and we can see that it's going to decrease in pounds per square inch as we go up, and this is going to a height of 10,560 feet, okay, which I believe is 2 miles. All right, so what we can do is we got to solve for p here, but if you check it out, everything we need is on this side, right? So what we can do is we can just compute this. All right, there's nothing to solve for here. This is just a substitution problem. And what we get is P is approximately 9.83 pounds per square inch. So 15 pounds reduced to 9.83 pounds per square inch. Okay. And then this last problem here, you can see we're solving for t again, so it's going to be similar to this problem. I specifically made this problem that this number is double whatever that number is, because sometimes you'll hear them talk about double time or the doubling time. Okay. And remember, for half-life, okay, for half-life, we wanted our start value, okay? We want our start value to go down in size. But for double time, okay, if they don't give you their doubling time, we want our start value to go to double in size. So here we are given the numbers, okay? But you're going to see what happens here when I divide by 10,500 and divide by 10,500. I get 2 is equal to e to the 0.15t. And you can think about, there's a 1 here, okay? So when you look at the doubling time, there's the start value and there's the end value, okay? So this is a doubling time problem. So now we have 2 is equal to e to the negative 0.015t. We can take the logarithm of this side, the logarithm of this side. we get ln of 2, or the natural log of 2, equals negative point. Oh, I don't know why I keep putting that negative in there. Lucky I'm catching myself. And then I'll divide by 0.015, divide by 0.015. I get t is approximately 46.21 years. Okay. Now, some of you might be taking another class where you hear about the rule of 70, or the rule of 72, and you might want to check out the doubling time. If you take your percentage, okay, you take your percentage, which is 1.5%, and divide it into, or divide 1.5 into 70, okay, you get roughly the doubling time. Okay, just something to explore if you want to look into things a little further. So that wraps up 15.8, and that is the last section that we cover in intermediate algebra. So good luck with it, and if you have questions, drop me an email. Thanks a lot.